Assalamualaikum warahmatullahi wabarakatuh. My name is Nuri Zunaira Mitizana and I will present introduction for mechanical distribution, electrical distribution and air conditioning system. Mechanical ventilation system use fans to bring in fresh air from outside and remove stale air from inside the building. This helps control the growth of molds and other airborne contaminants. Mechanical ventilation can be supplied by a heating and cooling unit, and fans can be mounted on walls, windows, and ducts. The type of ventilation used depends on the climate and location, with positive pressure being used in warm and humid areas and negative pressure being used in cool places or areas where pollutants are generated. For the electrical system, in building consists of a network of cables and devices that transport, distribute, and transform electricity from the source to the various loads through the building. The distribution system is responsible to carrying electricity from the transmission system substation to the customer meter and to the point of usage. Without the distribution system, the electrical power grid would be insufficient. There are three main types of distribution system design, which is radial, loop, and network. This system ensures the electricity is transported from the source of generation to the point of consumption. Air conditioning, or we can call AC, is the process of regulating the temperature and humidity inside a building or vehicle to improve comfort. It can be achieved through mechanical cooling system and other methods such as natural ventilation or passive cooling. The heating, ventilation, and air conditioning system is a combination of technology that work together to maintain appropriate temperature inside building. Most air conditioners use vapor compression refrigeration and come in various sizes from the small unit for cars and even individual rooms to the large one for entire building. Heat pumps, which can both heat and cool, are becoming more popular in regions with a harsh winter.
Hi, Assalamualaikum. My name is Noeni Barkis. AF200110 will present about background of all the systems. Firstly, mechanical ventilation system. In 1631, King Charles I mandated that homes have at least 10 foot ceilings and windows that are higher than the width of the room to allow for circulation. When it was recognized that poor indoor air quality might lead to health problems, American Hood, an American manufacturer of kitchen exhaust fans, has introduced a number of new products including a fire suppression system. If an abnormally high level of smoke and temperature is detected, a specific wet chemical agent is utilized in conjunction with a fire alarm system to provide rapid flame knockdown and increased fire prevention. Secondly, air conditioning system. This one luxurious innovation is now critical since it allows us to chill homes, workplaces, hospitals, data centers, laboratories, and other key structures for our daily lives and economy. A Florida doctor and inventor named John Gurry believed cooling might be the solution to battling disease in keeping people comfortable in the 1840s. Long before electricity was created, he developed an internal cooling system that entailed moving sizable slabs of ice from northern frozen lakes and streams to chill hospital rooms. He experimented with refrigeration and created a device that produced ice using steam, horsepower, or wind-powered sails. By the 1960s, central air conditioning was standard in the majority of newly built American homes. Lastly, about electrical distribution system. In 1882, Thomas Edison built the country's first power distribution system. Edison's design was revolutionary in that it separated the energy user from the energy source and its accompanying annoyances and risks, such as soot, smoke, and open flame. By replacing the practice of burning candles and lamps, Edison's distribution system increased the quality, safety, and cleanliness of illumination. AC had surpassed DC as the industry standard for delivering power by the late 1890s. Because of AC power technology, power companies could deliver both high voltage power and low voltage power to consumers.
It helps the speaker lead his audience into the scene described.
Assalamualaikum. My name is Melita Lindsay. My metric number is AFC00068. So here I want to present about the mechanical ventilation system that proposed for this project. So the building type that needs ventilation system is kitchen, bathroom 1 and 2, and the living room. So for the area of the kitchen is 16 meters squared, and the obtained airflow rate is 0.24 meter cube per second. So for the adjustment, we propose to install a ceiling fan. The next is the bathroom 1 and 2. The area of bathroom 1 is 8 meters square, and the obtained airflow rate for bathroom 1 is 0.06 meter cube per second. And next is area for bathroom 2 is 7.1 meters squared, and the obtained airflow rate is 0.05 meter cube per second. So the adjustment proposed for this bathroom is install ventilating fan. So last but not least is living room. So the living room area is 37.82 meters squared, and the obtained airflow rate for the living room is 0.23 meter cube per second, and the adjustment proposed for this living room is install a ceiling fan. So for the ceiling fan, we propose a junior fan that name K12B0 PDR. The spec for this fan is this fan have brown color. The number of blade is 3. The dimension is 48 inches or 120 cm. The energy star rating is 5. The RPM load is 151 until 177. And last but not least, the RPM height is 273 until 353. So the reason why we choose the fan is this fan has energy saving condenser motor. It also enhances with cut off safety device and blade safety brake, and it meets the COP or coefficient of performance requirement. Next is the ventilating fan. So for the model of this fan is KDK 3081A. For the spec, the RPM for this fan is 925 until 1085. The capacity is 727. The motor rating is 240 volt or 50 Hz. The motor W low is 31.8. The motor W height is 38.8. And the motor HP is 0.05. So the reason why we choose this fan is its high efficiency motor for energy saving. It also has dual blade design for perfect balance and quiet operation. It has thermal safety fuse, and last but not least, it's easy installation. That's all for me. Thank you.
My name is Nizanti. Next, I will present part 2, selection of air conditioning system. There is 3 building parts in layout for installation of aircon. First was bedroom 1. It has 34.6 meters square that is equal to 7,000 BTU. The room was fully exposed to sun, so after making an adjustment, it is 9,000 BTU, which equal to 1.0 HP. The same process is repeated for bedroom 2 and living room. For bedroom 2, we get 1.0 HP, and for living room, we get 1.5 HP. Okay, the product that we'll be using is Daikin FTKS standard R32 inverter. Okay, why we use this? Because FTKF series offer powerful year-round cooling to achieve optimum levels of comfort. The types of product is inverter, and it has energy rating of 4 star. The product refrigerant is R32. Its capacity was ranged between 1.0 until 2.5 HP. It heat exchanger using hydrophilic glue feed. The reason that we choose this product: first, has econo mode. It limits the maximum power consumption. Second, it has easy maintenance with removable drain pan. This reduces the cleaning time. The third one is smart control. It saves energy and maintains comfort for users. The fourth, anti-corrosion treatment. The surface is covered with a thin acrylic resin layer to enhance the film's resistance to sub-corrosion. And the last one, because it has zinc iron blue filter.
So then, why?
Hi, my name is Nurul Izzah Fatihah binti Zulkifli. I will present about my part, which is electrical distribution system. A distribution system is the electrical system that connects the transmission system substation to customer meters. The electrical power grid would be insufficient if distribution systems were not in place. A distribution network is required to carry electricity from a source of alternating current AC or direct current DC to the location where it will be used. The electrical power grid will be insufficient if distribution systems were not in place. A distribution network is required to transport electricity from a source of alternating current AC or direct current DC to the point of usage. Energy distribution from point of generation to the point of consumption can be pretty simple. Complex power distribution systems are used to transport electricity from the power plant to businesses, homes, and other locations that require it. There are three fundamental types of distribution system designs, which is radial. For this project report, we are required to come out with an electrical system plan. So this is the electrical system plan that our group has came up with, that consists of the switch, socket, air conditioning, and others.